Evidence for the expansion of the universe from galactic motion and redshift. Stephen Hawking states in his book, The Universe in a Nutshell, that the Doppler effect also applies to light waves. If a galaxy were to remain at a constant distance from Earth, distinctive spectral lines would appear at their normal or standard positions. However, if the galaxy is moving away from us, the light waves would appear longer or stretched, causing the distinctive lines to shift toward the red end of the spectrum to the right. If the galaxy is moving toward us, the waves would appear compressed, and the lines would shift toward the blue end of the spectrum, to the left. Yet observations made by Vesto Slipher and Edwin Hubble during the second decade of the 20th century revealed contradictions with the earlier static universe concept. In 1923, Hubble discovered that many faint patches of light known as nebulae were actually other galaxies, vast collections of stars like our Sun but located at enormous distances. For them to appear so small and faint, they must be incredibly far away, to the extent that their light takes millions or even billions of years to reach us. This alone indicates that the universe could not have begun merely thousands of years ago. Hubble made an even more astonishing discovery. Astronomers had learned that by analyzing the light coming from distant galaxies, they could determine whether those galaxies were moving toward us or away from us. To their surprise, they found that nearly all galaxies were receding. Moreover, the farther a galaxy was, the faster it appeared to move away. Hubble realized the profound implications of this discovery. On the largest scales, every galaxy is moving away from every other galaxy. The universe itself is expanding. After this groundbreaking discovery, humanity gradually abandoned the idea of a static universe, a concept that had dominated scientific thought for centuries. The image of a fixed and unchanging cosmos had been deeply rooted in the human imagination. But Hubble's measurements delivered a scientific shock of enormous magnitude. They demonstrated that galaxies are all moving away from one another. This does not mean that galaxies are flying through a rigid and motionless space. Rather, space itself is expanding continuously, causing every point within it to drift farther from every other point over time. This concept changes everything. It means that time is not merely a rigid sequence of events, but part of a greater cosmic story that began at a unique moment in the distant past. If the universe is expanding today, then logically, tracing time backward would reveal space gradually contracting until everything, matter, energy, space and time itself, was compressed into a single point, the moment we now call the Big Bang. Thus, redshift became more than a mere astronomical observation. It became profound evidence for the beginning of the universe itself. The light arriving from distant galaxies acts as a messenger from the past, carrying ancient signals that began their journey millions or billions of years ago. When we observe that more distant galaxies appear increasingly redshifted, we understand that the universe resembles a balloon being continuously inflated, where the distances between points on its surface increase, even though the points themselves are not moving across the surface. This is why every observer, no matter where they are located, appears to stand at the center of the expansion, even though in reality there is no single center at all. Space itself expands uniformly in every direction. This discovery also reshaped humanity's understanding of its place in the cosmos. Instead of existing at the center of all things, as ancient civilizations once believed, humanity came to realize that it inhabits a small planet orbiting an ordinary star on the outskirts of one galaxy within an immense universe that has been expanding and evolving for billions of years. As the years passed, measurements became increasingly precise, and Hubble's law was confirmed again and again until cosmic expansion became one of the foundational pillars of modern cosmology. These observations also led to even greater questions. Will this expansion continue forever? Will gravity eventually slow it down? Or might the distant future witness a cosmic contraction that returns everything to its origin? All of these questions are connected by one essential truth. The universe is not static, but exists in a state of continual transformation. Its ultimate fate remains a mystery that continues to inspire curiosity and challenge the human mind. Thus, redshift and the motion of galaxies became powerful evidence that the universe began from a tremendous event whose echoes still reverberate throughout the vast cosmos to this day. In this sense, the expansion of the universe stands as living evidence that the cosmos had a definite beginning and was not always as it is now. Rather, it came into existence at a moment when the laws of nature were set into motion by the will of the great Creator, and the universe began expanding according to a precise and orderly system that cannot reasonably be attributed to mere chance or chaos, but instead bears witness to the power of the Creator who brought this magnificent cosmic structure into existence from nothingness.